Okay, so hello everyone. Welcome again to my channel. And today we would be doing the second question of the Babbar DSA sheet. So we have already covered one question, and this is the second question. Let's see the question. The question says that given an integer array A of n elements, the task is to complete the function palin_array, which will return 1 if all the elements of the array are palindrome. Otherwise, it will return 0. So let's understand the question. Okay. So this is our question. Let's see. So we're given an integer array A of n elements. Okay. So the first thing that we know that we are given an array A of n elements. Let's say the elements to be A of 0, A of 1 till A of n. What we need to check is that every element should be a palindrome. Okay, so it says to us that every element should be a palindrome. And if this condition is satisfied, that is like A of 0 is a palindrome, it's palindrome, A of 1 is palindrome, and so on till A of n, it is palindrome. Then we know, then we have to do what is, we have to return 1. And if any of these elements is not a palindrome, that we then we return, else we return 0. Now, for those who don't know what is a palindrome, basically, so let's discuss a bit what is a palindrome. Yeah. So, what is a palindrome basically? So, a palindrome is something like it's something in the representation of, like, let's say we have a string s equals to a b c a b c, and we have another string s1 is equals to a c a d d a c a. Now, what is a palindrome? Like when we reverse the sequence, whether it be a string, whether it be a number, then when we reverse it, we get the same thing back. So for this case, let's reverse it. We would get CBA CBA. Now that's not equal to ABC ABC. But if we reverse this, we get ACAD DACA. You see, we get the same string back. So this is a palindrome. Okay. Let's come to the previous page. Sorry. Yeah. So let's take some example case. Just a second. Sorry, some mistake here. Wait. Just, yeah. Now it's fine. Now let's see the first test case. 5 1 1 1 2 2 2 3 3 0 4 4 4 5 5 5. Okay. So our first test case is n is equals to 5 and a of n is equals to 1 1 1 2 2 2 3 3 3 4 4 4 5 5 5. It's interesting. When we reverse 1 1 1 2 2 2, after reversing the arrays look something like this. 5 5 5. Easy. So it's equal, all the elements are equal to its previous form. So we are, the output is 1 is our output. And let's see for the next case. It's 3 1 2 1 1 3 1 20. It's n is equals to 3. A of n is equals to 1 2 1 1 3 1 and 20. So when we reverse 8, so we get 1 to 1, 1 3 1, but 20 will become 0 2. So that's why it's not equal. So that's why the output is 0 for this case. Let's now think of the approach. How can we do it? So for those who are new, every like many people would get a very straightforward, simple approach. There are two ways in which we can solve the problem. First is making the number as string, and the second way is letting the number be as it is. Letting the number be as it is. Okay, so let's label this as A and this as B. Now let's discuss the approach A and B. Yeah. Now for approach A, what do we want? We have converted the numbers into string. So let's say this is a string now. 1 1 1. Okay, this is a string now. There's a function in string called reverse, which reverses the string. So what do we want? We want to check that the reverse of the sequence is equal to the original sequence. Yeah. So what do we want? That reverse is equal to original. This is the condition for checking palindrome. Yeah. So there is a function named reverse. Then the string name, let's say str dot begin, comma str dot end. Okay. Quite easy function. And then the colon. This is in C++. So we want this reverse to be equal to original. Quite easy. Yeah. Nothing hard. So how could we do it? We will create string s, string, let's say original, which is the original string, and then we can create another string reverse or rev, which is equal to what? That's basically equal to reverse of. So that's the first we will have to do it equal to original. Then we would reverse rev dot begin and then rev dot end. Okay. So this is our code, and then if original is equal to rev, then we can easily continue, like we could continue the loop, else we have to return 0 because I have found one which is not a palindrome, so I can easily return from there. First way. Let's check out how can we do the second way. So the way B, we have the number, we have this 1 1 1, or let's take another palindrome for simplicity, 1 2 3 3 2 1. Okay, this is our palindrome. Okay, how can we check this is the number? How can we check that this is like a palindrome or not? We can't reverse a number. Like we don't have a built-in function. We can reverse a number. Now let's see how can we do that. So I have let's say wait. So I have int a, which is equal to 1 2 3 3 2 1. I can have an int rev, which is equal to reverse of a. So reverse is the function that we would be creating. Let's see how this reverse would look like. So it would be an int reverse of int a. You would find many codes online also for reversal of a number. So what do we want? How can we reverse it? It's very easy, It's literally very easy. We would just create an int reverse, which will equal to 0 at first. Then while a is not equal to 0, we have to simply multiply rev by 10 and then add a modulus 10 and then divide a by 10. Okay, and then at the end we need to return rev. Quite easy, I believe. When I will be coding this approach, and I will show you how does it work. Then I will tell you with the help of like a case that how does it work. Or if you want, let's see one case right now also. Let's take that 1 2 3 3 to 1 case only. So my A is 1 2. So we are basically running this code. How does it work? I'm on the first line. My A is 1 2 3 3 2 1. Second line, I am a rev equal to 0. Yeah. While A is not equal to 0. This condition is true. A is 1 2 3 3 2 1. I multiply rev by 10. So my now rev is equal to 0 only. 0 into 10, 0. Now I add rev with A modulo 10. So what is the remainder? 1. So my rev is now 1. And when I divide it by 10, the last digit gets eliminated. So my A is equal to 1 2 3 3 2. Now next way. Next time A is not equal to 0. I go again. So my rev is equal to this time 10. I multiply it with 10. 1 into 10, 10. And then I add the sum. So it's 1 2 3 3 2. So 2 would get eliminated and it would be 12. And my A again divided. So 1 2 3 3. I multiplied with 10. What do I get? Reverse, I get 120. This time I get 120. And then I add the remainder, I get 1 2 3. The last digit, of course, the last digit. And then A again divided by 10, only 1 2 3 left. So this way you see 1 2 3 I've already got. Let's go more further. So my rev would be again multiplied 1 2 3 0. Again 3 addition. Rev is equals to 1 2 3 3. Eliminated. A is equals to 1 2. Rev now equals to 1 2 3 3 0. Yeah, 2 eliminated. Like division, rev is equals to 1 2 3 3 2. A is equals to 1. Last, rev is equals to 1 2 3 3 2 0. Then the remainder 1 1 2 3 3 2 1. And finally A is 0. And we have got the correct reversal, and this is a palindrome. Okay, let's now, if you want to see the try run, you can see it again. Okay. Um, let's now see how to code these approaches. Oh, sorry. Okay. So the first approach, A approach, converting to string, I've already submitted. Let's see how I did it. So you see that in this approach, we are running a loop, checking all the elements from 0 to n. Then we are converting string. So how do we convert a integer to string? That's very easy. 2 underscore string a of I. You can write that. Then I've used a reverse. Instead of reverse, I've used string t, which is equal to s first, original string basically. Let's just see it in a better version. It's better if I use like appropriate names. Sorry, just a second. Let's. Yeah. So I use this as original. I use this as reverse. This is original. Then again rev, original, and rev. Now it's easy for you to understand. Original is equals to 2 underscore string a of I, which means the number is converted to int. Then we have string reverse, which is equal to original now. Reverse is equals to reverse. So we are reversing the rev string, which is the function I told you. Then if original is not equal to reverse, then we have to return 0. Like if we have got any such number which is not a palindrome, then we can return 0. And after coming out of the loop, that means that every number is a palindrome. Then we can easily write that the whole array is a palindrome array. Let's compile and run and submit this code. Just have changed the name. It would work, of course. Wait, what's wrong with it? Everything done. Oh, sorry. Wait. This is done. Yes, you see, I'll still submit for like for the sake of showing you that it works. So it works. Okay. Now let's take the next code, the second way to do this. So for that, we would have to make a function called int reverse, where we would be taking int a and then int rev is equals to 0. The same code, while a is not equal to 0, rev into is equals to 10, rev plus is equals to a modulo 10, and then a by equal to 10. Then we could just return rev. Now int a is equals to a of I. We can't use the a, sorry. So we could use original here also. In rev is equals to reverse of original. If original is not equal to rev, that means I've found some non-palindrome number, so I can return 0. Let's check this code if it runs or not. I hope that is run. Yeah, that does run. And let's submit it. Okay, so this is also like submitted. It's passing all the test cases. Okay, so this was all for today. Thank you. Have a nice day.